Hi guys, I hope everyone's doing well. I want to give you some extra practice with electron configuration for those of you who needed it. A little remediation course for you. On the right side here I have our electron configuration triangle, which we've been using, and then on the left side I have the chart we've been filling in during class. And I know some of you are getting away from this, which is great. Some of you still need it, which is fine. But overall we want to start using this, and then overall getting even away from that. So let's do an example. I figure we would start with rhodium. If you look at your periodic tables, our chemical symbol for rhodium is capital R, lowercase h, and our atomic number for rhodium is 45. If you recall, our atomic number is our number of protons, and don't forget we always want our number of protons and electrons to be equal. So if we have 45 protons, we also want 45 electrons. So what I'm going to do is I'm going to match up this over here with our triangle in order to use both of them at once, so you guys can see how you can use either one in order to complete the electron configuration. So I'll put our bright rays of sunshine over here, and then I will draw in our electrons on this side. So if we have 45 protons, as we said, we're going to put 45 electrons in. So let me switch my color here, and I'm going to put a 45 here just to say, hey, I need to put 45 electrons in. So let's start with our bright rays of sunshine. We're going to put our first ray of sunshine in, and it's going to cross through 1s. Now, we're going to go over here to our 1s orbital, and we're going to put one electron facing upward and one electron facing downward, which means they are going to have opposite spins. So far I have put 2 electrons in, 1, 2. After that, let's go to our second ray of sunshine. That's going to be our 2s. And we're going to go to our 2s orbital, 1 up, 1 down. So I have now put in 4 electrons. Let's see where we're going next. We are going to, with our third ray of sunshine, go through the 2p and the 3s. So start off with where the ray of sunshine would hit first, which would be our 2p. Don't forget Hund's rule. Hund's rule states that each of the orbitals of a sublevel have to get 1 electron first before we double them up. So we're going to give 1 electron here, 1 electron here, and 1 electron there, and then double them up, 1, 2, and 3. So far, if we count them up, we have put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So let me subtract that just to keep us organized. I have 35 left to put in. With that third ray of sunshine, we went through 2p, and now we are going to go through 3s. 1 up, 1 down. There's 2 more. Another ray of sunshine, fourth one. We are going to go through 3p and then 2 4s. So for 3p, again, Hund's rule, 3 up and 3 down. And after that, after 3p, we are going to go into 4s. So if you've noticed, we put another 10 electrons in. Again, to keep us organized, I'm going to subtract them, and I have 25 left to put in. Now, fifth ray of sunshine. We are going to go through a block where we have not gone to yet. It is our 3D. So we're going to go 3D, 4p, and then 5s. So for 3D, again, Hund's rule, each one gets an up one, and then we are going to put our down ones in. So if you notice, there is another 10 we put in just by using 3D. I'm going to subtract those. After 3D, we are going to go to our 4p. Let's put in some 4p. Hund's rule, up, 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 and then down, down, down. After 4p, we're going to go to our 5s and put 2 more in. So if we include our 4p and our 5s, we have put in 8 electrons there, and we have 7 left over. If you look here, our last ray of sunshine, we are going to go 4d, 5p, and 6s, where we won't even need the 5p and the 6s since we only have 7 electrons left to put in. And here's where Hund's rule really is important, because we are going to first go up, 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 and up. There's 5, 6, and 7, and that is the correct way to write our electron configuration. So we have the last 7 subtracted, and we have 0 electrons left to put in. So what I'm going to do is I'm going to erase this just to get it out of the way, our little scratch work there, and it's gone. Last thing we got to do is actually physically write out the electron configuration. And again, you can use both charts for this. You can use the left chart and the triangle for it. The triangle is nice because it can keep you organized with which ray of sunshine the blocks went through, first, second, third. But anyway, I'll start over here. We started with 1s. So we are going to write 1s. And then how many electrons do we put in there is going to be our exponent. So we put 2 in 1s, so it's 1s2. Followed by, where did we go second? We went to 2s. So that's going to be 2s, and we put 2 in there. Okay. After that, we went to 2p and 3s. So 2p, and how many did we put in 2p? 1, 2, 3, 4, 5, 6. After that, we went to 3s. Okay, so we have our 3s2. After that, we went to 3p. And we put 6 electrons in there. So if you notice, there is a trend here where all of the s's are going to have 2 electrons, and all of the p's are going to have 6. It's always going to be like that until the end. After 3p, we went to 4s, so that's going to be 4s2, followed by our next ray of sunshine, which was 3d. So in 3d, we put, it's getting big here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We put in 10. All right. After 3d, we went to 4p and 5s, and 4p we put 6 in. Switch sides here. Okay. After 5s is when we're going to go to our 4d, and our last one we put in 1, 2, 3, 4, 5, 6, 7. So here is our electron configuration for rhodium. All right, and that's how you write it out. I know this is a long way to do it. Tomorrow we are going to shorten things up a little bit, and I'll post another video with that. But for now, it's like crawling before you can walk. We got to do it the long way. So hopefully this helped you guys out a little bit. If you have any other questions with them or concerns, please bring them to class, and have a good rest of your day.